Hello, everyone. Thank you for joining me today with another set of notes with Mr. Jankowski. We're on page 98, and we're focusing on lesson 14.2, which is all about polygons on the coordinate plane. So, drawing two-dimensional shapes on a coordinate plane using ordered pairs. So, we have the question at the top of this page. I'm going to zoom in and get a good close look here, and I'm going to read what it says. Sheila wants to make a pattern of two different tile shapes on a floor. She first graphs the shapes on a coordinate plane. So she's going to graph two shapes on this coordinate plane, and these are going to be templates for her to make tiles. So if I scroll down a little bit, we have number one, plot these points to form one of the tile shapes. So what I'm going to do is I'm going to plot A, B, C, and D first. Then I'm going to connect the points in order and say what kind of polygon it forms. What kind of shape does it form? So let's take a look. A is 3, 5, the ordered pair 3, 5. So I'm going to go to 3, positive 3 on the x-axis, up to 5 on the y. And there's my first point, point A. All right, point B is 4, 6, so 4 on the x-axis, up to 6 on the y. There's point B. C is 5, 5, so 5 on the x-axis, 5 on the y. There's point C. And then point D, 4 on the x-axis, 4 on the y-axis. Here's point D. Now, if I start at A and I connect A and B together, then B and C together, then C and D together, and then finally D back to A, you can see that I have a rhombus shape here. A lot of people will say it's a diamond shape. It's actually a rhombus. A diamond is a mineral, one of the most abundant minerals we have actually in our on our planet in our solar system. But this is not a diamond shape. It's a rhombus. That's the first pattern. The next one is down here, and we're going to call this number 2. Sheila is going to plot these points as well, and we're going to see what kind of shape that makes. I'm going to do this in red, and I'm going to be going up and down because I need to look at these different points. There's a lot more to plot here. So P is first, negative 5, 2. So negative 5 on the x-axis, 2 on the y. There's P. All right, next is Q, a negative 4, 3. So negative 4 on the x-axis, 3 on the y. There's Q. R is 0 on the x-axis, 3 on the y. There is R. S is 1 on the x-axis, 2 on the y. There's S. T is 1, negative 2, so 1, and then down to negative 2 is T. U is 0 and negative 3, so 0 on the x-axis, down to negative 3 on the y. This is U. V is negative 4, negative 3, so negative 4 on the x-axis, negative 3 on the y. There is V. And then finally, we have W, negative 5 on the x-axis, negative 2 on the y. So negative 5 on the x-axis, negative 2 on the y. There we go. There's W. When I connect these points, starting from P to Q, and then Q to R, and R to S, S to T, T to U, U to V, V to W. I'm going to redo that one. V to W, and then W to P again. And what kind of shape do we have? Well, we have, let's see, 1, 2, 3, 4, 5, 6, 7, 8 sides. And we have 1, 2, 3, 4, 5, 6, 7, 8 vertices. So this must be an octagon. Okay. Now, the next question, question number 3, says, how is the number of vertices related to the number of sides of a polygon and to the type of polygon? Give 2 examples. Well, vertices are the corners where the polygon shape turns. So in this case, the points are where the vertices are located at. Now, it has the same amount of vertices as it does sides, and that's something we can mention here. How is the number of vertices related to the number of sides? Well, we could say the number of vertices equal the number of sides of a polygon, of the polygon. Well, any polygon, really. And to give you some examples, let me fix this one here really quick. To give you some examples, a square, well, that has 4 vertices, 4 corners, and 4 sides. Likewise, a triangle has 3 vertices and 3 sides. We can look at our octagon as well. Our octagon has 8 vertices and 8 sides. Our rhombus, which kind of looks like a square just tilted sideways, has 4 vertices, 4 sides. So you have 2 examples. There are many others if you want to use something different. I'm going to zoom out so you can see the whole page here. There it is. Remember that this video can be stopped, paused, rewound, watched again, shared with friends and family. So if you ever get stuck on something on this page or other pages that are talking about polygons on the coordinate plane, you can always revert back to this video. Thank you for watching, everyone. We'll see you in the next one.